Problem number 19. The textbook gives us the function y equals x cubed. And then it asks us to find the tangent line that crosses through the point 1, 1. So we're asked to find the tangent line and the normal line. Okay? So to find the tangent line, we just need to take the derivative of this, evaluate it at 1. So what I want is I want f prime of 1. Well, we've defined that, and there's lots of ways you could do this, but we've defined that as f of a plus h, but I'm just going to say, or x plus h, I'm just going to say 1 plus h minus f of 1 all over h. Oh, I forgot to write down that we need the limit of this, right? So it's like the limit of this as h approaches 0. Well, I can't plug in the 0 because h is on the bottom. So on the next line, we want f prime evaluated at 1. Now, you guys know where the 1 comes from, right?
Yeah.
We're interested in the x value 1. And so, and let me write this out a little clearer because I forgot to write it down before. We're going to take the limit of all this stuff as h approaches 0. Well, what's f of 1 plus h?
1 plus h.
Yeah, so it would be like 1 plus h cubed minus 1 cubed, right? Because it's x cubed all over h. Next line, f prime of the limit of this stuff as h approaches 0. If I expand this out, I'm going to get 1 plus h times 1 plus h times 1 plus h. So if I do those, I'm going to get 1 squared plus 2h plus h squared. And that's got to be times 1 plus h. Right? Mm-hmm. Well, 1 squared is just 1. So I'm going to say 1 plus h times 1 times plus 2h plus h squared. So I've got 1, 2h, h squared, and this becomes h, 2h squared, and then h cubed. So if I combine like terms, I get 1 plus 3h plus 3h squared plus h cubed minus, what's 1 cubed? 1. All over h. Well, we know that at this point, we want to double check our work. Every term that doesn't have an h in it should cancel, and it does. 1 minus 1 is 1. And so this term has an h in it, this one has an h in it, and this one has an h in it. So I can factor out an h. So in the next step, I'll say f prime evaluated at 1 is equal to the limit of 3, wait, let's pull the h out, h times 3 plus 3h plus h squared all over h as h approaches 0. Now we know that those h's will cancel. And in the next line, I'm simply going to plug in 0 for h. So it's 3 plus 3 times 0 plus 0 squared, which gives me 3.
That's the answer.
Well, that's the answer, but what is this? This is the slope of the tangent line. Right? So you're like, wow, I understood what you did, Mr. Adams. Great. Well, we've only just begun.
So then we just do point slope.
So now, yeah, so for the tangent line, we do, and Mr. Adams uses a little bit different point slope form. I say x minus x sub 1, and normally you have minus y sub 1. I just move it over to the other side, and when I do that, it becomes plus y sub 1. And remember, our point 1 comma 1, that's where it has to cross through, so that's really my x sub 1 comma y sub 1, right?
Yep.
So I'm going to say y is equal to my slope, which is 3, times x minus 1 plus 1. Distribute that through, and I get 3x minus 3 plus 1, or y equals 3x plus 2. That should be the tangent line, right?
Minus 2.
Is it minus? Oh, yeah, it's minus 2. Sorry, I got so excited. Minus 2. Now, how could I verify that? Graph them both. So what I'm going to do is I'm going to turn on my calculator, and I'm going to graph the parent function, which is going to be x cubed. And then I'm going to graph my tangent line, 3x minus 2, and they should intersect at what point? 1 comma 1. And looky here, I think it does. So if I hit trace and I enter in 1, it's 1 comma 1. And if I zoom in a little bit, yeah, that's where it intersects at, right? Perfect.
It's like magic.
Now the normal line has to be perpendicular to this line. So how do I write the normal line? Well, the normal line is perpendicular to this line. So we still do the same thing. It's an equation of the line,
Reciprocal.
the negative reciprocal, but it's still going to pass through the point 1 comma 1, except now we're going to say y equals m times the quantity x minus x sub 1 plus y sub 1, except I'm going to have the negative reciprocal, which is going to be negative 1/3, right? Times x minus 1 plus 1. Distribute that through the parentheses. I have negative 1 over 3x plus 1/3 plus 1. Well, what's 1 and 1/3 as an improper fraction? Yeah, so I've got 1/3 x plus 4/3, and this should be the equation of the normal line. Well, let's graph it and see. Now I have to confess that when we graph this, it won't look like it's exactly a 90-degree angle because your calculator is a little skewed. It's stretched out a little bit more horizontally, but it is. So what I'm going to do is I'm going to say negative 1 divided by 3, and I'm going to put that in parentheses. Times x minus, and then in parentheses again I'm going to say 4 divided by 3, and graph it. Uh-oh. What did I do wrong?
Everything.
Did I graph that right? Let's see if I graphed it right.
Plus 4.
Ah, it's plus 4/3. See?
Why do we do the negative reciprocal?
Because the normal line.
The normal line is perpendicular to the tangent line.
They're perpendicular, right? So what do we know about the slopes of perpendicular lines?
Negative reciprocal.
Negative reciprocals.
Yes.
All right, now if Mr. Adams enters it in the calculator correctly, it crosses at guess what point?
1,
1, 1.
1. Now, does that look like a 90-degree angle?
No.
Not really, but it is.
Somewhat.
It's close enough.
Well, my voice just is really good.
If you were to graph this on graph paper, it would look more like it. I think that was it, right? Was that what we were supposed to do?
How about 21?
Yeah. Wait, Mr. Adams, I have a question.
Lay it on me, sister.